Hi everyone. Very good evening. Good evening, ma'am.
Good evening, sir.
Yeah, yeah. We can straight away go to the day 2 session, ma'am. Please.
Okay,
Yeah,
I can start?
yeah, ma'am. Of course, you can start, please.
Okay. 1 minute. Okay, so in yesterday lecture, we learned about some descriptive analysis as well as some data visualization part. There is a one chart left that is a box plot as well as the scatter diagram. Okay, so first I start with the box plot. What is box plot and how to draw a box plot in R? Okay, everyone able to see my screen? Hello.
Yes, ma'am. It's visible. Your R studio is visible.
Okay. So in yesterday lecture, we discussed for 5 things. One is mean, second is median, then the mode, then quartile, range, and interquartile range. Okay. So what is box plot? Actually, a box plot is also called as a 5-number summary plot. So what are these 5 numbers? Okay. So the first number is a median. Second is a Q1, that is quartile 1. Third is a Q3. And the fourth is a IQR. And the last is a range. If we want to plot all these values in a one shot, in a one plot, then we can use the box plot. Okay, so box plot is also called as a 5-number summary plot. Okay, so you can see this code. So what are the different types of input we can take in R? The first type of input we already see in yesterday lecture, that is using the vector. Okay, so we create a vector and we use a vector to do different type of calculation or different type of descriptive analysis. The second way is what we used is a CSV files. Okay, that saved in your hard disk or some another drives. Okay, so these two way we already checked. In today's lecture, we check the inbuilt data set that is available in the R. Okay, so there are 3 types of input that we can use in a R. First is a creating a vector. Second is using a inbuilt file, that is a CSV files or the Excel files. And third is a using the inbuilt data set. Okay, so what is inbuilt data set? So for example, in this code, I write this empty cars. Okay. So what is empty cars? Empty cars is an inbuilt data set that is already available in R. Okay. R have various type of database that is already available, and we can use the data set for different type of analysis. Okay. This is a data set that is used to calculate the different types of the cylinder values, miles per gallon, and the mileage of data set. So this is a data set based on these types of parameters. So how to access these data from R into our script? So first I have to declare a one variable in that I store the values. Okay. So if I want to take all the data set, 1 minute, please. Please, 1 minute. sorry. So if we have to assign the data set that is already available in our variable, then I take a one variable input. This is my data set, that name is empty cars. Okay, and I want to access all the rows but only two columns. That name is MPG and second column name is CYL. What I am doing here, I write here, I want to access all rows but only two columns of empty cars data set. Okay, so what I can do, this comma represent all rows. Okay, this comma represent all rows. Then I have to create a vector because I want to access two columns, not one column. So I have to create a vector, that is C, and I have to pass the column names that I want to use. So first column is MPG and second column is CYL. Okay, first I here give you means what is this empty car data set. For example, if I print here, print empty cars. Okay, and if I run only this line, you can see this is my whole empty car data set. Okay, here the first column is MPG, second column is CYL, third is display, HP dart. These are the different columns that is already available and already available with the RStudio. Okay, so we don't want to access from any hard drive or any different drives to access. Okay, so I want to use these two only columns to draw a box plot. Okay, so this data set is very large. So what is this head part do? What is this head part do? The head is used to print first 5 rows of data set. So if you want to print only the 5 rows of this input variable, what is in the input variable? All rows but only 2 columns, and I have to print only 5 rows, then I can use this head method here. Okay, so if I run this, what you can see, these are the only 5 rows, first 5 rows, and these only 2 columns of the data set. Understand everyone? Okay, so next what we have to do, I have to plot a box plot. What is box plot? Box plot is also, I told you that it's also called the 5-number summary plot. 5-number summary plot. Okay, what do you mean by 5 numbers? The first is a Q1, then Q2, then Q3, then range, and IQR. Okay, these are the 5 values. Okay, so for plotting a box plot, I have to use the method box plot. Okay, then which 2 column I want to use? I want to use 2 column. The first name is MPG, second name is cylinder. Okay, and this symbol is a tilde symbol that is available in your keyboard, that is used for the relationship. If you want to show the relationship between 2, then this tilde symbol is used. Okay, And what data set I am using? The data set is a empty cards. Then we already discussed this. X lab, that is X axis name. Y lab, that is Y axis name. And main is basically the chart name. Okay. Then if I run this code, you can see this type of chart is drawn. Okay. I again run. Okay. This chart is drawn. So what is this chart and how you discuss what is Q1, what is Q3 and what is Q2 in this plot. So this dark line you can see, everyone please understand, this dark line part is a Q2. Okay. This line, this is a rectangle. This lower line is a Q1. This upper line is a Q3. So what this rectangle show? The middle line, dark line represent Q2 means median. This represent Q1, that is quartile 1, and this represent quartile 3, that is Q3. Okay. Then what is range? This range is basically the difference between Q3 minus Q1, that is IQR. And what this shows, this bar shows, this value is Q1 minus 1.5 IQR, and this is Q3 plus 1.5 IQR. What are these and why we are representing here these? Because this box plot is used in the outlier analysis. So outliers, if you want to find the outliers in your data set, if the data set lies below this point and above this point, then the data set or the data point is considered as the outliers. Okay. So this is the minimum and maximum range that you can accommodate in your data set. If your data set doesn't belong in this range, then the data set is called as the outlier and that is not used in your study. Everyone please understand or not? This is Q1 minus 1.5 IQR, this value, and this is Q1 plus 1.5 IQR. That maximum range allowed to consider data not an outlier. But if above or below this point, that data is considered as a outlier and not used in the study. Everyone understand with me or not? Is your chart prepared or not? Okay. Now, let's discuss how to find the correlation. Okay. So, anyone has any idea about what is correlation? What is correlation? So, correlation is between the 2 points, okay, or the 2 variables. And if we want to find the degree of association between the 2 points, we use the correlation analysis. For example, there is a one that is the sales and marketing. What marketing impact in the sales? What is the relationship between height and weight of a person? So there are 2 variables in a correlation analysis. One is called as an independent variable and second is called as a dependent variable. And we have to find out what is the degree of association between these 2. Okay. So the correlation values lies between, anyone please tell me what is correlation value? So correlation lies between -1 to +1. Okay. So what is not 0 to 1, it's a -1 to +1. Okay. So what do you mean by minus 1? There is a negative correlation also exists. Okay. Yes. Minus 1 means a perfect negative correlation and plus 1 means a perfect positive correlation. And what do you mean by 0? Means there is no correlation between these two variables. And if the values lie between 0 to 0.5, either in positive or in the negative, we can say that there is a moderate positive correlation or moderate negative correlation between X and Y. Okay. So here I use your data set that I already given you. That is a which data? For example, housing data. Okay. This housing data I am using to find the correlation. Okay. So I take the path. So first I take input. Here I pass the total path. And my file name is housing.csv. Okay. Now let's print. For example, if I want to print only 5 rows, then I give head and input. Okay. So it head gives the only 5 rows of this data set. First 5 rows. Okay. So this is the data set. Okay. There are these number of columns are there. For example, the area, the price, the bedroom, bathroom, number of stories, guest room, basement, all this. Okay. So I can take on 2 variables. For example, how area is dependent on the price, and or what is the association between the area and the price. For example, if I want to take, so how I can write, for example, I take a one variable correlation value. There is a method COR, okay, that is used for the correlation. And here I have to put our 2 columns. So first column is input dollar, for example, price. Second is input dollar, for example, area. Okay. Now, if I print this value, you can see the correlation value is 0.5359973. So you can say that there is a positive correlation between X and Y, or between area and price. It means if area increases, the price of the housing also increases. All you are with me? Everyone done with this or not? Everyone completed this? Please message me so I can move forward. If any problem, then you can post me in a chat. Everyone done with this? Okay, so in tomorrow's, in yesterday's session, we are talking about the conditional, means how to use a conditional variable or the conditions in the R. Okay, so let we do, means if I want to print the correlation is positive, then there is a positive correlation, and if negative, then there is a negative correlation. Then how to do? Okay, in the same program. For example, if I write here, if correlation value is less than 0. Okay. So what I have to print? I have to print there is negative correlation. Okay. Then what is else part? I can print there is a positive correlation. Okay. Understand how to write if else statement? If I run this code, you can see that there is a positive correlation. Also, you can get the value. Understand? Please do by yourself. If done, then message me. And if any doubt, then please post in chat. How to do conditional. Okay, I will copy the code. But please change the path of the file. Okay. Because if you are not changing the path of the file, then it might be possible your code cannot run. Everyone get the code? Okay. If done, then please let me know. Then I can move forward. So there is a is code complete? Completed? Hello. Okay. There is a one question also, means how to round the values. Yes. There is a question that what code to use the round the values to the 2 decimal. So there is a one method I use also here, that is round. Okay, so you have to round the value, then how many decimal places? For example, 2 decimal places, and you can write this. Okay, so if I use this here, now if I run this code, you can see this value is only in the 2 decimal. Okay, so I think you get the answer. Okay, so there is a round function, and in round function you have to pass the value, comma, number of decimal, how many number of decimal you want to print. Okay, so next we can start with the next we can start with the regression analysis, okay, or the linear regression. Okay, so in the linear regression there is a two variables, that is a x and y. One is an independent variable, second is a dependent variable, and if I want to form or draw a line, straight line between these two, there are some errors in the points. So how to reduce this error? There is a one method that is called as a least square method. So what is the equation of the linear regression? For example, I consider the y is dependent and x is independent. Okay, variable. Then the regression equation is y equal to a plus bx. Okay, so what is a and b? A is called intercept and b is the slope. Okay, and b is slope. So what we have to do in the regression analysis, there are two columns, and we have to form a regression equation, that is y on x. What is the meaning of y on x? In y on x, y is dependent variable and x is independent variable. For example, if I consider x is dependent, okay, then equation is x equal to a plus by. Okay, so either the equation is y on x, means y is dependent and x is independent. The another form is, if we consider x is dependent, then the equation is x on y. So equation is x equal to a plus by. Okay, so let me do how to perform a linear regression in this RStudio. Okay, okay, for example, in this code you can see that there is a two variable, one is x and second is a y, and I consider these two as a vectors. It is important and it is must that the number of values in x and the number of values in y must be equal. Okay, so to perform the linear regression or to find the a and b value, there is a method that is called as LM. Okay, And if your equation is y on x, means y is dependent and x is independent, then you have to pass accordingly y, then this is a tilde symbol, x. Okay, it means that y is dependent and x is independent. Okay, now if you print here the relation, it shows the value of a and b in for the regression equation. Okay, let I run this code. You can see this. This is my intercept and this is my slope. This is the value of a and this is the value of b. Okay, okay, everyone. Okay, let's we do this for the housing data set, means how to find the regression equation between price and the area for the housing data set. Okay, so I write this new equation, new script. I take the same code. Okay, this housing data set. Now I have to find the relationship between two, and to form the linear regression equation, I take a one variable, that is relation equal to lm. Okay, lm is a method, and y on x. For example, I take the price as a dependent variable and area as an independent. So I have to pass input dollar price till input dollar area. Okay, then if I print here relation, then it gives the intercept and slope value. Okay, you can see this. Now, how to form the equation? Our equation is y equal to a plus bx. Okay, so in our equation, what is y? Y is a dependent, so I take the y as price. So price equal to, what is my a? That is my intercept. The value is 2387308. It should be noted that these values can't be separated. We cannot separate these values into different variables. Okay, plus 462 into, for example, area. Okay, now let's, if I have to predict the value of price depending on the given value of the area. For example, given area equal to, for example, 1200 square feet. Then what is the price of the flat, or what is the price of the house? So what I have to give? I have to take a one variable, that is area equal to 1200. Now I have to write price equal to and area. Okay. Now if I print price if I send the file before to you, that you can't able to do by yourself, and you can't able to handle the errors. So I think it's not a good idea to send you all the files before. It's my opinion. And if sir allowed me, then I send you. I don't have any problem. But according to my opinion, it is not good for you. Otherwise, you don't understand the errors you are handling. Okay. Sir, is it okay to send before? Okay. So this is how to predict the price of the housing given on the basis of the given area. Okay. Understand everyone? Okay. Now there is a one chart that is used to show the correlation or the association between two variables, that is known as the scatter plot. Then how to plot a scatter diagram? Okay. So scatter diagram is same as the line chart, but in the line chart you see that there is a lines between the points, but in the scatter chart there is no lines between the point. We have to show the only points. And what is the difference? We have to also show the relationship between these two. Okay. So I have to change change some part in the code to see means what is the difference. Okay. So this is how I have to put, for example. Okay. So the method is a y, means y means, what is y in our case? Y is input dollar price. Okay. What is x out? X in our case, input dollar area. Okay. Then color you can choose, that color you can want. Then what you want to show? The area and price regression. Okay. Then you have to pass this method AB line. Okay. This method AB line is used to show the regression. Okay. Regression, AB line. And here you have to pass whole regression equation. That is LM okay. Then X lab. X is a dependent, independent. So independent is our area and in Y lab we have to put the price. Okay. If I run this code, you can see this, our scatter chart. Everyone is with me? So what is the difference between line and plot? The same method is used. In also line diagram, the method name is plot. But what is the difference? This AB line. Okay. If you pass this AB line, this parameter in a line chart, your line chart converted into a scatter chart or scatter diagram. Everyone done with this chart here? Okay. So there is a one data set diabetes. Everyone have this data set diabetes? Can all of you select any two columns, take one as an independent and second as a dependent, and make a scatter chart for this diabetes data set? Hello? Okay. And what to change if you are taking X as independent and Y as dependent? Then you have to pass here the area and here the price. Okay. Then your equation is X on Y, not Y on X. Okay. I think everyone has done. And if any problem in this diagram, you can post in a chat. And if you want this code in a chat, then you can also ping me or post. I can give you this code in a chat box. Can I send? Or everyone done with? Okay. Who's this program is done, please try with the diabetes data set, because it is important that you can use every data set and how to change in the code if your data set is changed. Okay, everyone done this? Okay. So next we want to start sampling. Okay. Before doing the any type of inferential study, that is a hypothesis testing, we first know what is a sampling, what are the different type of sampling, and how to do random sampling. Okay. So I will start with the random sampling. Okay. So how to generate a random samples from the data set? It is important that if your data set size is very large, then you cannot perform the analysis in the whole data set. You have to choose. I cannot understand your question. What do you mean by more areas? It means you want to do a multiple regression. Okay. Can I complete this sampling after that I told you? Because that is not the part of the workshop, but I told you. Okay. Okay. So when there is a large data set available, you cannot do the analysis on the whole data set. Then you have to select the random data set from the given data set. Okay. So mostly in the cases, mostly in the data analysis cases, we are using a random sampling. Okay. So how to do random sampling in R? For example, there is a one data set. Okay, this is a one data set I have taken, and I want to select any 4 random samples from this data set. Then how to get this? There is a one method that is called as sample. In the sample method, you have to pass your data, and then you have to pass how many samples you want to get. And in the result of executing this code, you get any 4 random samples from this data set. For example, if I run this code, okay, these are the 5 samples. These are the 4 samples you get. If I again run this code, you can see that this data is changed. If I again run, again data is changed. Why? Because this is a random sample. Every time when you run this code, the data set is changed because we are doing a random sampling. Understand my point? Okay. So what is the method that is used to perform the random sampling? The method name is sample. You have to pass 2 parameters in the method. First is a data, that is the input, and second is a how many number of samples you want to get. Okay. This is for the vector. Now we can also use this for our CSV files. Is this done? Then I use the CSV file. Okay. For example, if I want to use the CSV file and generate the random samples, then how to generate the random samples? For example, I use the file housing. Okay. and I want to generate any 4 or any 10 or 20 random samples from the column price or for the column area. Okay, so I want to write result equal to sample, then I have to pass input dollar, for example the area, comma, number of samples I want to get. For example, I want 20 samples. Okay, then I have to print result. So what we get, you can see I get the 20 data from the area column. Everyone understand? Okay. Now what to do if I want to get any random data from all the columns and all the rows? Then nothing to do. You have to pass just this. Okay. One minute. It takes only one column data at a time. Okay. Now take the whole columns. Okay. Now there is a 2 types of random sampling. What are the 2 types? One is random sampling What do you mean by period? Can you please explain what do you mean by period? This is not a time series data set actually. In the time series, there is a different types of methods are used for sampling. And also the time in the time series data set, data should be shorted according to time. And we have to do the basically not the random sampling. We have to do the either cluster sampling between the periods. So we can get the data set from all the clusters or all the periods that you want to analyze. If something else you want to know about the period or I cannot get it, what you want to say, then you can write in the chat. Okay. So what are the 2 different types of random sampling? One is a random sample without replacement, and second is with replacement. So what is the difference between without and with replacement? Is anyone has any idea? What is the difference between random sampling with replacement and without replacement? Okay, I tell you. For example, there is only 10 students in a class, and I have to give the task to every student. That is different from each other. Then I have minimum have the 10 chits, okay, to allocate the different tasks to the everyone. Okay, so this is a case that everyone comes and take one chit and go back and perform their task. Okay, so this is a case of a random sampling without replacement. But what do you mean by with replacement? If there is a 10 student but I have only 8 chits, then what I can to do, I have to do 8 students select their chits and 2 students if left, then I have to told to 2 students to give their chits back, and the remaining 2 students take these chits only. It means that the probability of these 2 chits is increased in a sampling. So this is a case with the with replacement. Okay, so what in real life, what scenarios are there where we have to use the yes, sample one again. So what in the real life situation, what are the cases? For example, if you want to do a survey, and in the survey you want to ask to the people, do you have a hepatitis, for example. So it's a general scenario, human always say no. Okay, so when you see your data set after collecting these records, you can see that the yes cases are very less in compared to the no cases. But for the data analysis, your data should be balanced, not imbalanced data set. So in that cases, in the no cases, you have to resample the data and you have to increase the sample size using the with replacement. So in that cases, you have to use the random sampling with replacement. So if your sample size is large, there is no need of the replacement. But if your sample size is very small, then you have to perform the random sampling with replacement to get the more data set to analyze. And there is a big problem if your data set is not balanced. So you have to balance the data set using the with replacement technology, with replacement method. Everyone get this? What is the difference between with replacement and without replacement? Okay, then let's discuss how to do this random sampling with replacement. Okay, so by default, if I use this sample method, it perform random sampling without replacement. Okay, so what to do if I want to perform the random sampling with replacement? I have to pass for example, I have to find the 10 data sets, and there is a one parameter replace equal to, I have to pass 2. Okay, so if replace equal to true, it means it perform random sampling with a replacement. Okay, by default, if you don't pass any parameter, this is random sampling without replacement. If you want to perform with replacement, then you have to pass the additional parameter, that is replace equal to true. Okay, now what is the difference in result? The data set size is very large, so you can't see the result. For example, I take one data set okay, and there is only 4 data set, but I want to generate 10 samples from 4 data sets. Okay, the data set size is only 4, but the sample size is 10. It is compulsory that we have to perform the random sampling with replacement. Okay, so what is the result? You can see this. The 20 is repeated many times, 30 is repeated, the 10 is repeated. So if your sample size is very small and you want to generate more samples from the less sample size, then you have to perform the random sampling with replacement. You understand my point? If your sample size is large, then there is no need to do the replacement. Understand or not? Okay. Then you can see in the random sampling with replacement, it is system choice that how many times 20 is repeated, how many times 10 is repeated, how many times 30 is repeated. But what to do if you want to customize how many times 40 is repeated, how many times 30 is repeated? Means you want to decide, means which data priority is high. If you want to select this data more time, then you have to decide what probability you have to give to a particular data. Then what to do? We have to do random sampling with replacement, and we have also have to give the probability values. Okay, how to do? I show you. One. Okay. For example, this is my data. The data sizes, you can see this is there is only 5 data. Then if you want to get 10 random samples from the 5 data set, it is compulsory that you have to use the random sampling with replacement. Okay, so you can pass here sample, then data size, replace equal to 2. Okay, then what is that mean? Okay, there is 5 data set. I have to give the probability to each, means which data has the what probability and how many times this data come. The total probability sum must be equal to 1. Okay, for example, I want that the 23 has the 60% probability to come in a random sample, and the rest data has only 10% probability to come in the random sample. So I can pass 0.6 with respect to 23 and rest 0.1 with respect to the other data set. Okay, now if I run this code, you can see that how 23 get the probabilities. You can see that the maximum time you see the result 23 occurs. Why? Because I give the probability to 23 highest. Now if I change, for example, I change here 0.3, and this is 0.2, this is also 0.2, and for example, I given here 0.0, so 3, 2, 5, 7, 9, and this is 2. Okay, what is that meaning? I don't want that 5 comes in my random sample. Okay, so let's see what is the result. You can see that 5 never occurs. The highest probability is having 23, then 23 occurs the 4 times. You can see 5 times. Okay. Understand or not how to give the probabilities to each value while selecting the random samples? You must check that the sum of the probabilities must be equal to 1. Understand? Everyone? Okay. Now, let's do the hypothesis testing. Okay. Anyone has any idea about hypothesis? What is hypothesis? Okay. Hypothesis. Yes, there are 2 types of hypothesis: null hypothesis and alternate hypothesis. But what is hypothesis? Hypothesis is our assumption. For example, if I tell you that if the marketing price increases, if the marketing cost increases, the price of the product increases. Okay, so this is my assumption. It might be possible this my assumption is true or my assumption is false. If I want to check my assumption is true or false, then we have to perform the hypothesis testing. Okay, so there is a 2 type of hypothesis. There is a 2 form of the hypothesis. One is a null hypothesis and second is a alternate hypothesis. So what are the different terms we require to check the hypothesis? The first we should know what are the different steps of the hypothesis testing. Everyone know what are the steps of hypothesis testing? Yes or no? If no, then I show you means. I show you once means what are the steps, because we are using encoding, so everyone has to understand means how to perform these steps. The first step is to define the null hypothesis and the alternate hypothesis. Okay, when we are defining the null and hypothesis, null and alternate hypothesis, there is either a one-sided hypothesis or there is a two-sided hypothesis. Okay, so what do you mean by one-sided hypothesis? One-sided means we are checking the less than or greater than case. Okay, but if we are checking the if we are checking the equal to cases, okay, then in that case we have the hypothesis is a two-sided hypothesis. Okay, so what are the steps we are using? Basically, the first step is to define the null and alternate hypothesis. The second step is to define the sample size. What is the sample size we are using? It depends on the sample size, means which test we are using. So there are in your workshop we are covering 2 tests. One is called as Z test and second is called as T test. So what is Z test? Z test is used for large sample when your sample size is greater than 30. Okay, and if your sample size is greater than 30, according to the algorithms, it assume that your sample size is a normal. Okay, and if your sample size is less than 30, in that case we are using the T test. Okay, so we according to the sample size we decide we have to use Z test or we have to use the T test. The next step is we have to define that what is our level of significance. Okay, so what is level of significance means how much error we are accommodated. Mostly in general we are testing three level of significance, that is either 5%, either 10%, or either 1%. Okay, that we are mostly testing. Then we have to perform the Z test, and according to the Z test value, we have to conclude that null hypothesis is accepted or rejected. And on the basis of that, finally we have to write the conclusion. Okay. So what are the steps you can understand? First is defining the null and alternate hypothesis. Second, you have to you have to know that what is your sample size. Third, you have to define the level of significance. Fourth, you have to decide according to your sample size which test you are using. Next, you have to perform that test, and after that you have to conclude that null hypothesis accepted or rejected based on the test value according to the given level of significance. Okay. Understand? I will share you a PPT for same. Now, what? Okay. Let's say we have a one data. This is our data set. Okay. I have to check that the population mean is equal to 3 or not. So what is my null hypothesis? I write here null hypothesis defining with H naught. I write the sample mean is equal to population of mean. Okay. You can also write the alternate hypothesis, that is HA, the sample mean is not equal to population mean. Okay. I have to check that with from these two, which is true for our data set. If your sample size is large, in that case always the population mean is given. Okay. So for example, I here take, this is my data set. Okay. And given the population mean is 3. Given. Okay. And if your sample size is large, the standard deviation value is also given. What is the standard deviation? Then how to calculate the standard deviation? Anyone know how to calculate the standard deviation? For example, if I want to calculate the standard deviation, then I have to write SD of X. Okay. This SD of X gives the standard deviation of this data. And what about variance? If I write here variance of X, it gives the variance. Okay. But this is sample standard deviation, not population standard deviation. One minute. Okay, 1 minute. I passed the variable name wrong. Okay, this is the variance value and this is the standard deviation. Standard deviation is the square root of the variance. Okay. Now, how to know the length, means sample size of the data set? There is a method that is length. Okay. So, if I want to manually calculate, then it's okay. But if I want not to manually calculate it with the and with the help of the method, then we have to use the length method. Okay. So it return the number of elements in the X. Now, what is the formula for Z test? This is a X bar, means mean of X minus population mean divided by sigma. Sigma means your standard deviation divided by square root of n. This is the manual formula of Z test. That is X bar minus mu. Mu means population mean divided by sigma upon root n. This sigma upon root n is also called as standard error. Okay. This gives you the Z calculated value. Okay. Now, what about the table value? Because we have to test that your calculated value is either less than or the greater than of the table value. So, to calculate the table value, we have to use this Q norm method. Okay. If your level of significance, here I write, if level of significance is 5%, okay, means alpha, your alpha equal to 0.05, okay. Then what is the alpha by 2 value for two-sided test? That is 0.025. Okay. Then what you have to pass in the Q norm? You have to pass 0.975. If you pass 0.975, it gives you a level of significance 95% two-sided test table value. Okay, and that is 1.96. You can check in the table also, that value is 1.96. Now, what is the rule? If your calculated value is less than the table value, in that case, you can write null hypothesis accepted. Otherwise, you can write null hypothesis rejected. Okay, so I write here Null hypothesis rejected. Yes, yes, I show you. Okay, I repeat you. So first, I assume here that the test is a Z test. Okay. So for Z test, if your level of significance is 95%. Okay. So what is alpha? Alpha is 0.05. Now we also assume this test is a two-sided test. It means this alpha value is divided both the side of the normal curve. It means the one-sided value is 0.25. In normal, when we are seeing the Z table, we have to give it either less than value or the greater than value. Mostly tables gives you a less than values in Z test cases. So less than means only 0.025 value is minus from the confidence value. So my confidence value is 1, total area is 1. So I minus 1 minus 0.025. So what is my output? That is 0.975. So I have to pass 0.975 to get the table value of 95% confidence level for Z test. Understand? Why I pass 0.975, not 95? If the test is one-sided test, then I don't have to divide this value by 2. I just pass 0.95. But I assume here that the test is a two-sided test. So I have to divide the error by 2. So my error is 0.025. Understand? Yes or no? No? Then how do I show you? One minute. If I have a table, then I show you. Sorry, I don't have table, but I show you with the PPT. You able to see? Able to see this PPT? Yes or no? Okay. So this is my normal curve. Okay. This is the area where I can see that probability that hypothesis is true. Null hypothesis is true. So I assume that in that question, the level of significance or the confidence value to accept null hypothesis is 95%. So what is this? My 95% reason? This whole reason is 95%. Okay. Then how much percent reason left? 5%. So 5% is 0.025 this side and 0.025 this side. Understand or not? Okay. So when we are looking into a table, the table gives you only one-sided value. One-sided means This is only less than values. Okay, so in less than values, how much percent error we are accommodating? Only 2.5% or 5%? One-sided means if we divide this curve by 2, then how much percent error we have? 2.5%. Okay, means we have to minus this value, because this whole is a less than area for this particular region. My region is, this region is 2.5%. Okay, and this whole is 97.5%. So total is 1%. So this whole less than area I have to cover. So I pass this value 0.975 here. It's not 0.25, it's 0.025. Okay, because it's not 25%, it's 2.5%. Okay, understand? Okay, now if I run this code, you can see that my calculated value is 2.371. Table value is 1.9599, as my calculated Z value is greater than table value. What is the result? Null hypothesis rejected. Then what I conclude? That the sample mean is not equal to population mean. Understand? Okay. There is also a way to perform a Z test using the inbuilt method. Okay. There is also an inbuilt method. You don't have to use this whole formula. Now, how to do this? And this is a one sample test. Okay, this is not two sample, this is a one sample test. For example, I can also show you means how to do with the CSV file, all this. This is my CSV file. Okay. Then to apply Z test, I have to write Z dot test, comma, the column name. For example, I use input dollar area. Okay. Then I perform only one-sided test, so the y is null. Then I assume that this test is a two-sided test, so I pass alternative equal to two-sided. Okay. Now, if population mean is given, then I can pass the population mean. If population mean is not given, then I can pass mu equal to 0 because I don't know what is the mu. Now, I can pass the confidence. So confidence dot level equal to, for example, I assume the confidence level is 95%. So I pass 0.95. Okay. And I store this value into a result. Now, if I print result, one minute. I think I have to the z function cannot be found here. So the library I have to install. Okay. One minute. So there is no space. For this, we have to install one library, I think. One minute. I check. same library is showing, but I think it's not supported for this version. I will told you later, means how to use this. I find out, I will find out means what is the library for same. Okay. The one way you know that we can use with the manually with the using the formula of Z test. I will told you tomorrow. Okay. Okay, not a problem. Okay, now there is a one question for the multiple regression. Okay, so I will show you means how to do the multiple regression. So for example, I use this data set only. So what is my multiple regression equation? So this equation is y equal to a plus b1 x1 plus b2 x2 plus b3 x3 and so on. Okay, so here x1 x2 x3 all are the independent variable while y is a dependent variable. So how to perform this? We have to pass, use the LM method. So I have to pass LM. Okay, then I have to pass the dependent variable. Okay, while for example I take dependent input dollar price. Okay, then I have to pass the spin symbol. Now I have to give the all the independent variable I want. Okay, for example I want input dollar area plus input dollar bedrooms plus input dollar bathrooms. Okay, now if I print result, you can see that there is a one intercept, but there is a one slope, but there is a three intercepts. You can check this. There is a one intercept, but there is a three slopes. Understand? So what is my equation? Y equal to A. What is A? This is A. Plus, this is B1, this is B2, this is B3. Understand? Okay. So this way we can perform the multiple regression. You can take any number of the independent variables. Understand? Okay. Now, how to do the hypothesis testing? using t-test. Okay, so I already told you when your sample size is small, means less than 30, in that case you can apply the t-test. What is the difference between a t-test and z-test? In t-test is basically a z-test is basically gives the value on the basis of the population data set, while t-test is used for the sample data set. Okay, so sample is given, the sample mean is not given, the sample standard deviation is not given, and you have to calculate the t-test value. In z-test, you know that the population mean must be given, population standard deviation must be given to calculate the z-test value. So how to calculate the t-test value for one sample? Okay, now let us discuss. I take this data only to apply the t-test. Okay, this is my data set. First, I have to write the hypothesis. So I write hypothesis, null hypothesis. That is, for example, the population mean of housing price is equal to sample price. Okay. Then what is my alternate hypothesis? Opposite of this. Okay. Now, first I have to calculate the mean of the data. I use here housing price, so I take the column price only. So first I have to calculate the mean. So for example, mean of price equal to mean, then input dollar price. Okay. Then what I have to calculate? Standard deviation. So SD of price equal to, the method name is SD, that input dollar price. Okay. Now the formula is, now I have to calculate the length of the sample. So n equal to length input dollar price. Now I have to calculate the t stat value equal to, what is the formula? That is x bar minus mu. Here I consider mu equal to 0 divided by sigma upon root n. So I have to write the mean of price divided by standard deviation. So SD of price divided by SQRT of n. Okay. Now I have to calculate the table value of t. Okay. So this t. Now let's print. Okay. So to calculate the table value of t, the method is qt. Okay. To calculate the table value of z, the method name is q norm. To calculate the table value of t, the method name is qt. In qt, you have to pass two things. Okay. First, you have to pass the level of significance. Second, you have to pass the degree of freedom. So what is degree of freedom? Is n minus 1. Why n minus 1? Because we are using a one sample test. If the sample, there are two samples, then the degree of freedom is n1 plus n2 minus 2. But here, there is only one sample, only one column. So degree of freedom is n minus 1. So I have to pass two things. One is level of significance. So my level of significance, if I consider this 95%, so 0.975 for two-sided test. And then I have to pass the degree of freedom. Okay. Now I print this value. Now I have to write the rule. Okay. So what is the rule? If P stat is less than T table, it means null hypothesis accepted, else null hypothesis rejected. Okay. Now, if I run this code, you can see I pass print all these values, so there is no chance of error. Okay, not a problem. These values are correct. Okay. So this value is our T calculated value. This value is the T table value, and the table value is less than the calculated value. So we can say that null hypothesis is rejected. It means that the population mean of housing prices is not equal to sample price. Not equal to sample price. Understand how to perform t-test? One sample, two-sided t-test. This is one sample, two-sided t-test. Everyone understand or not? Okay. For two column, we have to for two sample, we have to do all these for the second sample also. Then you have to change the formula for two sample test. Rest all is same. Okay. Any query in today's session? In today's session, we cover the box plot, the scatter diagram, the linear regression, correlation, multiple regression, hypothesis testing for one sample Z test and hypothesis testing for one sample T test. Okay. For rejection and acceptance, there are two rules. One rule is based on the test value. Second rule is based on the p value. Okay. When you do these codes in the SPSS, okay, or in the Python, okay, there is a p values. Okay. So if the p value is less than the 0.05, in that case, for 95% significance, you can say that null hypothesis accepted. Okay. But for if you want to compare your value with the test value, then the case is if your calculated value is less than table value, then null hypothesis rejected, otherwise accepted. Less than table value, then accepted, otherwise rejected. Understand? Your table value must be, your calculated value must be less than table value to accept the null hypothesis. Okay. And if you compare with the p value, then if your p value is less than 0.05 for 95% significance, then null hypothesis accepted, otherwise rejected. Okay. Okay. Any more query for today's session? In tomorrow's lecture, we cover the two-sided test as well as the chi-square test. Okay, that is a non-parametric test. These are called as a parametric test, Z test and P test. So we cover the non-parametric test in tomorrow's session. Okay. I will share you all the codes with sir. Okay, no problem.
Yeah,
Everyone
okay.
has any query,
Okay,
then
ma'am, thank you.
post
I
in the
think
chat.
no more doubts left. You have cleared all the doubts in time to time.
Yes, sir.
I think no more doubts left because
Okay.
we covered all the doubts in timely manner.
Okay.
Yeah.
Okay, sir. Thank you. I will share you all the codes, sir, and you please share with the students.
Yeah, sure, madam.
Yeah. Okay.
Thank you, ma'am. Thank you, everyone, for joining today's session, and we can meet on tomorrow.
Yeah.
Yeah. Thank you. Good night.